I'm Hannah Clark and I'm the Executive Secretary for the IAGOS Research Infrastructure, working at the IAGOS head office. We work with different airlines around the world so that our data is as global as possible. And our most recent collaboration is with Air Canada. We explained to them how the data collected by their aircraft would be used to measure pollutants from wildfires and how that data would be used in the Copernicus Atmosphere Monitoring Service to validate and improve the air quality forecasts. This has been clearly demonstrated this summer because of the enormous wildfires over Alberta, which we managed to capture with the IAGOS aircraft. The air quality over Canada and North America has been extremely poor, and this has been an issue which we expect to worsen with climate change.
So I'm Thibaut, I'm a PhD student and my time is shared between IAGOS and Météo France. And my subject is about carbon monoxide anomalies related to biomass burning. And this is an increasingly important issue with impact on air quality and climate. And this is also the role of a research infrastructure like IAGOS, because, for example, they can give the climatological context of a pollution episode by characterizing its intensity and duration and compare it with other episodes in the previous 30 years.
I'm Julie Pachiel, I'm a research scientist and I've been working for IAGOS for a couple of months. And I've been looking at the generation of nitrogen oxides from lightning and the impact they have on the budget of ozone in the upper troposphere and lower stratosphere.
I am Romain Blot and I am a member of the IAGOS France technical team. There are many steps in preparing an aircraft for monitoring, beginning with the legal agreement with the airline, the identification of the suitable aircraft and availability of that aircraft on the ground for the fitting. The scientific equipment need to be prepared for installation, and specific installation kits are built by the STC holder of the IAGOS system, which is currently Sabena Technics in Bordeaux. The scientific equipment are scheduled to make automatic measurements during 6 months. No action from us or from the airline crew is required. The system sends the data automatically after the flight on the ground when the passengers are boarding. After 6 months, the instruments are replaced by a maintained and calibrated instrument. The calibration is made in our lab in Toulouse, and the maintenance is performed by a Part 145 company in order to release an EASA Form 1 certificate, which is mandatory to fulfill airworthiness safety regulation. Installation takes about 3 weeks, and it is performed in the maintenance center of the airline. In total, the system is about 150 kilos. It can happen anywhere in the world. For example, last winter I spent 3 weeks in Hong Kong to supervise the installation of a new Air Canada aircraft. From agreements with the airlines to the first collected measurement in flight, it takes approximately 2 years.
What I like about atmospheric research infrastructure is their open data policies, because they are responsible to measure the atmosphere, and so without them we would have much less data to conduct our research and to make sure that our models are working properly. So to me they're essential to the atmospheric research.